Hello everyone, this is now Fialkov speaking and my partner is Barkoslavsky. In this short clip, we would like to present you our Maze3D final project in the course Algorithmic Programming in Java. So let's get started. In the course Algorithmic Programming in Java, we were asked to solve the general search issue. We wish to resolve this issue by a series of actions leading from the start position to the goal position. In our project, we focus on creating a three-dimensional maze and solving it using search algorithms like the BFS and the DFS. These algorithms create the development of the junction, but differ when choosing the next junction to be developed. Now, I would like to elaborate how the BFS algorithm works. The best first search is a search algorithm, which explores a graph by expanding the most promising node chosen according to a specified role. As we can see in the following pseudocode, we use a priority queue and set of nodes. For each iteration, we dequeue the best node for the priority queue and put it in the set of nodes. Then, we check if we reach the goal position. If not, we will keep searching for successor and add it to the priority queue. The successor with the lowest cost we will put in the sets. The second algorithm is the depth first search. The DFS is an algorithm for traversing or searching tree or graph data structure. It starts at the root and explores as far as possible along each branch before backtracking. As we can see in this pseudocode, the DFS, unlike the BFS algorithm, uses a stack instead of a queue, and it delays checking whether a vertex has been discovered until the vertex is popped from the stack. Now, after we learn how the search algorithms work, let's see the game in action. As we can see, a GUI display pops up, and if you want to turn off the background music, we can press the on and off button. Now, for the example, let's generate a new maze by fill all the fields. We should pick up a name and a design for the 3D new maze. The maze is ready. Now let's display the maze, write down the maze name. This is our new maze. As you can see, the little character moves. These movements occur according to the up, down, left and right keyboard arrows, and if we want to switch between the maze floors, we can press on the page up and down button. Like this. Okay. If we are tired of to find out the right path, it is possible to click the Solve button and choose in which way we want to solve this maze, whether using the BFS algorithm or the DFS algorithm. Let's write down the maze name and choose the BFS algorithm. Now let's display the solution. And now the character will move along the path till it gets to the goal position. Yay, we win! After we're done to play, we will close the game window by pressing the X button or the exit button. Let's press the exit button. And we will see that all the processes are shut down without the error message, and there are not threads that still running behind the scenes. Now, let's talk about the architectural patterns. In our project, we use the MVP design, a model view presenter. The MVP pattern separates responsibilities across three components. 1. The model. Model can be thought of as an interface to the data. Any part of the program which needs some data to work on must go through the interface or function defined by the developer who is maintaining the model part. 2. The view. View, as the name implies, is a part where user interacts. The development of this part can be delegated to a specialized designer. A program may have any number of views. Presenter. All the business logic required for responding to a user events in writing inside the presenter layer. Typically, the view only has the event handler and the logic to call appropriate presenter function. Presenter is also responsible for retrieve the request data from the model and tell it to the view. Then the view can respond to it without any overhead. Let's go back to the code for a minute and we will see how we implemented this pattern in our project. As you can see, We have model, presenter, and a view in separate packages. Now, how it works. At first, the user starts the game by pressing on the generate buttons. Behind the scenes, the view sends a notification. The view doesn't know who will get this notification. The event handler delegates to the presenter with the user command that the view sent. The presenter doesn't know how to do this command, so it activates the model. After the model gets the command, and it will be execute the generate method, and will send a notification that the command completed successfully. This notify will send to the presenter, and the presenter will send a model information to the view. In this case, the presenter sent the new 3D maze to the view, and finally, the view will display the maze on the screen. That's it for now. Thanks for watching. Hope you enjoyed.